Um, Today I'll be solving Weekly Contest 150. It started 2 minutes ago. So let me open all these problems. Okay, so just a simple for loop, other than say nums length I++, and then int sum equal 0 if nums I, if so there are going to be I minus k less greater or equal 0, then I'll do and nums I minus k okay, and nums I greater than num I minus k, and so here or I minus k less or 0, and then here a similar condition for the plus if I plus k are less than n. Let's say we have int n equals nums length, and then here n, then here up to n, and then if it's I plus k is less than n, and then if nums I greater than nums I plus k, or nums plus k greater or equal n. Then I wanna add to the result sum plus equal nums I, and then return some about this one. So we have k2 output 12, k matching, k1 output 2 matching. Okay, make it smaller, submit. Next one. So 2D integer array squares. Okay, I have like coordinates xi, coordinate of the top probably, and the length. Bottom left point, bottom left. Okay, the square parallel to x axis. Find the minimum y coordinate. Am I recording? Yeah, I'm recording. The audio, what is the audio? Okay, that's fine. So there is a separate square. Find the minimum y coordinate value of all horizontal line such that the total area of the squares above the line equals the total area of the squares below the line. What if it cuts the square in between? Okay, should be overlapping area should be counted multiple times. Okay, so here, oh, they have even good example. So what I can do here, I was thinking right now about binary search and like doing like, let's say I have a bunch of squares here, here, and say here. If I, how many squares are there? 5 to the power of 10, 5 to the power of 10 of the 4. So what can I potentially do? For every square that ends at, let's say, we have like multiple squares here. Let's say this one has area 2, this one has area 3, this one has area 2, this one has area, let's say, 1. And then I can record incremental area. So every time the square bounds changes, or like every time the square is over by y axis, I can go like 2, and then incremental here gonna be 5, and then here gonna be 7, and then here gonna be 8, and then I can do the binary search. Yeah, I can do the binary search for the let's say we have maximum is 8, so we need to do binary search for roughly f4, and like 4 should be 4 should be so I should find the next closest bound that's greater or equal than 4. So the bound should be this bound that I'm doing binary search. It should be greater or equal to 4, and then it should be like next closest one. And then if I'm gonna find it, then I can actually not do the binary search. I can do just linear search, and then I can find also the when it starts. So it starts Here I saw like two starts here, lower bound, then 3 starts here. So yeah, I was thinking that maybe I can do a linear function, but actually, like here, like it grows, like until this point it grows, the area grows like so I have, let's say, area here on, so so the on y-axis I have, when it's like, let's say, this one is not actually the y-axis marks, they are area marks. Area at this bound area at this bound, area at this bound, and this probably, let's say this one gonna be 1, let's say this one gonna be 3, 4, and this is gonna be 5, and then area at this bound at 5, and then I can probably have a lower bound. Let's say this one gonna be 4.5, and this one gonna be 3.5, 3.5, yeah, like this, 3.5, and this probably gonna be half. So I should start looking like I have like area 5, or like area, say 4. So it should be start looking below area 7, because it's like the discrete value, and I should go down and probably I should be looking between between this 3 and 4. And probably should be there also binary, there should be binary search, probably. What if there are like couple of, so the problem with this approach, I find this approach, let's say we have a couple of squares that end at specific y, and in this case I have like, if I'm gonna do binary search, I'll probably will not find this one, because like it's not linear function, the area here is not linear function. So let's say the area function gonna be area gonna be y until, let's say, y1. It's gonna be say it has like widths of, let's say, v1, and this one has widths of v2. So it's gonna be area gonna be v1 by y if y is less or equal y1, and then I'm gonna change to area v1 y plus v2. Oh no, it's gonna be v1 y, and that's gonna be y0, y minus y0, and then here gonna be v1 y minus y0 plus w2 y minus y1. And that's the problem, because like even like this binary search was under, it might so I have the function. Okay, I have the function that should do the binary search. So I have like a total area equals sum of let's say I from 0 to n, and then here gonna be wi for widths of the rectangle, and then here gonna be y minus yi is 0. It's where the this rectangle starts. And then it's gonna be function of this. It's gonna be either v1 by y is 0 y, let's say y1 I minus y0 I, if y greater than y1 I, if y is greater than y0 I, but y less than y1 I, is gonna be v1 y minus y I0, or otherwise if y is less than y I0, it's gonna be just 0. And then I need to sum all this, sum all of this, and then I need to find that y that splits this area function into, let's say we have total A, and then that splits that at total A over 2. So it's like seems like very nonlinear function, because like it changes itself in nonlinear. So like let's say we have like two rectangles here, and then in this case the area, let's say here y0, here gonna be y1 or y2, here gonna be y1, and the area gonna grow a little bit different. So here v1, v2, let's say starting from y0, here y, starting from y0, it grows like what? It grows, this is area function, so it grows like, so before that it was 0, then it grows with the rate of v1, something like that, and then no, initially it actually grows with v1 plus v2, and then here gonna be the slope gonna be v1 plus v2, and then up to the reaching y1 it changes its slope, and maybe it's gonna be less steep, more flat, and just v2. And then when it reaches y1, it's gonna be just flat. So, and I need to find the y, let's say y underscore, or maybe just y yt, that split the area in half. So it should be like some kind of this value of yt, where let's say we have a total, and then a target gonna have a over a total over 2. How to do that? How to do that? So if I have all squares bounds again, how many people saw this question? Oh, there are quite a few solved. So I keep thinking about having these bounds when it starts and ends, when rectangle starts and ends. So let's say I found the upper bound. And let's say I found the lower bound. And I can figure out like how many rectangles are there and what their wides. And I need to just go sum the wides, y1, w1 plus w2, let's say in this case. So first of all, I add the y's. So here, let's say we have this one. Here width's 1 and height's 2, and so it starts at 0 and it's 2, and then I'll have, let's say, another one starts at 1 and say it has weights 3, and then it adds at 3, so it has a height of 2. Let's say we have then we have like other rectangle 1 by 1, and it starts at 3 and at 4. So here I will order those rectangles by y axis, and then I'll do the incremental areas. So the first incremental area gonna be over like at 2. So it's gonna be 4, and then the next one at 2, 4, and then I have at 3 I have 6 plus 2, 10. This one area 4, this one area 6, this one area 1, and then so I have 2, 4, then I have 3, 10, and then I have 4, 11, and then I need to figure out like what the closest bound to 11 over 2. So like it's gonna be closest upper bound, so it's gonna be 5.5. So the closest bound, upper bound to 5.5 is this one, because it has 10 value, and then I need to figure out like when it starts when this bound starts. And it starts at this at 2. At 2, and there is just one rectangle between 2 and 3. Let's say they were like another rectangle here, couple of like overlapping rectangles. Then I would, so like in order to find this bound, I need to take whatever like number of whites we have, like white in this like between 2 and 3, and there is just one rectangle now, so it's gonna be 3 by, let's say, so the previous one was 4, the current one is 10, and the target is 5.5. So I need to find, so it's like 4 plus v, so like 3 by y I should find target equals 5.5, and then this one gonna be 1.5 equals 3 yt, and this is gonna be yt minus y, let's say 0. In this case y0 is like in this case it's 1, so yt minus 1, and then I need to like 1.5 divide over 3 plus 1 is gonna be yt. And let's say we have a couple of rectangles that end at the specific upper bound, and let's say this one has y0, y1 0, and this one starts at y2 0, and this one starts at y3 0, and then this one has w1 whites, and this one has w2 whites, and this one has w3 whites, and then and I need to, let's say if I figure out that area should lay somewhere here, like yt should lay somewhere there. So the area there should be like all rectangles that ended below this upper bound. Or it might be even like this one. Oh, in this case it will not be the case, because yeah, so like all rectangles that ended below the bound, so it's going to be a something lower. So the formula going to be a lower plus v1 y minus y1 0 plus w2 y minus y2 0 plus w3 y minus y3 0, and this should be equal y, like not y, it should be equal a t, something like that. and this is the equation of just so I should do this move AL, so it's gonna be something like this: AT minus AL minus V1 Y0 minus V2 W2 02 minus W3 minus W2 Y02 minus W3 Y03, and then this one divided by W1 plus W2 plus W3, and this 8 target, yeah, and that's gonna be formula for Y target. So I should basically add up all this weights, and then I should also, it's such a like implementation wise it's a little bit difficult, but yeah, I wonder if there is a shortcut somewhere. Whatever. So let me first do that. Arrays sort by squares by this function int square 1 int square 2, and then I'll have this integer compare square 1. So I want to sort by y. Square 1 square 2 1. That can be returned. And then I wanna do this. Do what? I wanna have this incremental array. So it's gonna be int mul a gonna be new int, and then int n equals squares length, and then cumulative area gonna be just this array, and then I'm gonna do for int I equals 0 other than n I plus plus, and then cumulative area gonna be cumulative area I minus 1 if I minus 1 greater or equals 0, otherwise it's gonna be 0, and then plus square squares. Say we have SQS here, SQS, and then here gonna be lengths. Oh, so it's so I didn't get it. So like I didn't get it that it's a squares. It's actually squares. It simplifies a little bit, but still squares. SQS. So 2 by SQS 2. I'll have double, and then int target area gonna be cumulative area I n minus 1 over 2 2.0 I'll say double, and then I need to go and find the bound where the so I need to go one by one and enqueue the rectangles that starts and dequeue the rectangles that ended. So I'll have the double trailing area, and then I'll have the queue, and then int, and then queue equals new linked list int, and then I'll have this for int I equals 0, I less than and I plus, and then I'll do so I need somehow like efficiently enqueue in the queue the so every time I add a rectangle, I need to dequeue trailing rectangles that have that ended below its start point, the current start point. So I have this while queue peak. So the current triangle, current square gonna be int square equals QS I, and then Q peak, while Q peak, and then this triangle gonna end by what area? Well, let's say double current area equals, let's say, equals 0, and then trailing area equals 0, and then while Q peak, so the y when it's gonna be end gonna be 1 plus, so it's plus L is less or equal say just less or less or equal current rectangle square, current square start for y. I'm gonna do int trailing square equals q all, and then trailing area plus equal trailing square length by trailing square length, and then I'll do the I should do like not by I. So if there are a bunch of squares that are like aligned on the top, I need to add them all to the queue. So while I less than n and squares I is equal I, and then it starts at 1 plus L gonna equal squares square 1 plus 2, and here's sq2. I need to do this procedure then I plus plus then current area plus equal sq sqs I L SKS I2 by SKS I2. So like that, and then I need to enqueue the SKS Q, let's say Q dot offer SQS I. And then as soon as if current area if current area is greater or equal target area, then I wanna break, and then I wanna calculate the target, and it's gonna be all rectangles that are in a queue, and then I need to do this current, so I need to follow this formula. So it's gonna be target area minus that's gonna be trailing area divided by sum of weights, and then okay, so while q not empty, q is empty, I'm gonna have int, or let's say double sum of weights equals 0, and then I'll need to int square equals q.ball, and then I'll do the following. So they double so left LHA's left hand side gonna be target area minus training area, and then I have this ball sum of weights, and I'll have double sum of multiples equals 0, and then sum of weights gonna be increased as plus equal square 2, and then sum of products, say sum of products, sum of prods, some weights, some prods gonna be also incremented by square, so it starts at y, so it's gonna be 1 by square 2, so like that, and then return LHS over LHS multiplied by sum of prods, sum of weights divided by LHS minus sum of prods LHS minus, so this is LHS, this is sum of prods, so I need to subtract LHS minus sum of prods divided by sum of weights, something like this. Will it work? This is crazy. SQ cumulative area, I here and I here. SQ peak 2. Oh no, this one's not right. So this, let's quickly check like why it's not right in this one case. So here should be cumulative area. So cumulative area should be like at I'm thinking right now how to order the squares. Should I order them differently? So, what's the problem with this solution right now? So these two squares, they're gonna be they're gonna end at this like 2, oh yeah, and 2, and then gonna be cumulative area So according to this formula, will it work? Will this formula work? So I have the squares. So if I this one, so cumulative area system out println cumulative area what's gonna be here 4 and 5. So here 4 and 5. It's first this if I gonna order it differently, if they're so I'm gonna have if a square I plus square 1 plus square 2 when it's gonna be over the square 1 is equal square 2 plus square 2 then I need to return integer compare square 1 then square 2 otherwise I wanna compare square 1 plus 2 and then here also square 1 plus 2 here still. So cumulative area goes as following. If I do this -1, so at first okay, so first the first triangle is over, and this one, and then the second triangle is over, and then here I check trailing area. Target area is gonna be 2.5. Let's print it out. Print then target area plus target area. So target area 2.5, yes, and then I have this queue, and while this queue's length is plus current one, it should be vice versa, probably. Oh no, it shouldn't. While it's not empty, so I try to cut the current one. So let's print current area. Okay, system out and current area, and then with current area plus target area plus target area. So current area is 5. Target area, okay, not target, I want a trailing area. Trailing area should be 0. Okay, trailing area is 0. So here it should be sum of whites I wonder if this formula is not working. Why it's not working? So like they have like a target 2.5 minus the whites first. The first one whites 1 multiplied by it starts at 1 minus 0. It starts at so the length the whites 2 over 1 plus 2, and it's gonna be oh, it's not target area, it's gonna be current area. 1 3 3 3 3. No, not really. So here top area gonna be 5. And here is not target actually. No, not current area. Should be target area. Target area. So target area minus trailing area gonna be 2.5. Minus trailing area gonna be 0. And then I subtract v1 by y1, y1. So like minus 1, minus 0, and I divide it by v1 plus v2 is gonna be 3. So it's gonna be 2.5 over 3. Over 3 gonna be what? No. Why it is not matching? Yeah, something is wrong with the formula. What's gonna be sum of prod, sum of whites? Some prods. Some whites 3. LHS gonna be target area. (2.5) minus trailing area minus 0. So let's figure out if I got the formula right. Will it work at all? So in this case, I'll have this v1 v1. So weights of the second one gonna be 2 by y plus y minus 1 by 1 gonna should be equal 2.5. So 2.5 minus so here is I messed up with the minus sign. So here should be minus some prods. So plus some prods. Okay. So let me check if that works. What if I gonna do this one? No, still. So this squares, what it has? So it has one square that starts at 29, and it has the whites plot 29. This one 23 bytes of 3. And other one also starts at 29 and has bytes of 4. So this one 4, 4. This one 3, 3. So they started at the same level, but actually they go upper, and this one goes a little bit upper than the first one. So this one goes a little bit upper than the first one. So I need what the formula in this case gonna look like. So if I'm gonna run this one, cumulative area, trailing area, sum of whites, sum of rods. Okay. I'm gonna use this case. So here I have what? This one is so I have like two cumulative area gonna be cumulative area 9 and then 25. What? Why 25? Oh, because 9 plus 16 gonna be 25. 25. My output seems logical, but is it about this one? No. queue size. What's the queue size there? Queue size. One. What if I change it? It should be 2. So this one, if I reach this one, so when this one is over, it's gonna be 9, and 25 over 2 gonna be 25 over 2 gonna be 13 something, 12.5. So clearly this so when I'm gonna be 3 and 3 here, 3 by 3 here, 9, and that's gonna be 3 by 4, 12. So it's already out. So something is broken in my reasoning. I feel that there should be some ordering, like custom ordering here, and cannot figure out. Current area, trailing area. So I want this one to be first one in this order. If it's equal, oh no, if it's equal, then I wanna so in this case, will it be area, cumulative area 9, okay, and then 25, okay, then here if I arrive Q is empty, so I wanna have all these rectangles that are why that rectangle is excluded? The question is, why the first rectangle is excluded? Here. Q size. So I have like first rectangle and I check if the next rectangle, okay, I check INQ that trailing square gonna be trailing square gonna be what, 9? Yeah, 9. Current area gonna be 9, and I'm gonna offer the current one. Then I'm gonna check the next one. Need to somehow figure out the formula for this. Who are those people, I wonder? So the Q gonna be what? So in this case, current area, trailing area. I feel that this should be moving boundary. Top bound, let's say top bound equals SQI SQS I 1 plus SQS I 2, and that top bound gonna be so I wanna have so it's like sliding window approach, and every time the square gonna be over if I NQ the current triangle. I should NQ all the triangles that are aligned on the top. And I should DQ all the triangles that are lower that lower bound. One. Pick. If it's lower bound, so in this case, I should do like I NQ the first one. I try this rectangle. Okay. Okay, I'm gonna stop the recording. It was not that successful. Okay, thank you for watching.